Hello everyone, welcome to Learn Overflow. In this video, we will see the second type of solution for the problem that is the search suggestion system. So in my last video, I have already explained what this problem is, how we can solve this using a priority queue approach, and what is its complexity, and what are the things you need to know and all. So if you haven't watched that video yet, make sure you watch that first to understand what the question is and how the question needs to be approached over here. The last video will be there in the I button, and also make sure to check the description for the video link. You will find it both the places. Now let's move into a new approach to this particular question. So the new approach will be using a trie. So whenever we come across questions with multiple strings, it is the best to think if trie can help us. What we need here is a way to search for all the words with a given prefix, right? So in that case, this is well-known problem that trie can solve for us. So we will go ahead and try this with a trie approach. Say, like as an example, if you don't know how trie works, say there's an array like this, and in that case, if we are interested how trie would work on this, then this will be the root of the trie, right? This will be the root, and then followed by this, it will be like that H being common in all, and then E and I is there, like the second letter is there, and then post E there's an R, and post I there is an M is possible, and there is a S is possible. So that's how a trie actually works for us. Okay. So this is a try for us. So what would be the algorithm to just break into this? Well, we first like to create a try from this products array. Okay, so we had this products array, if you remember. So we will create a try from this and then iterate through the each character of this search word, this string search word, iterate through this, adding like it to the prefix to search it. Okay, like you, with each being added as a prefix, like the same thing we did over here, like we just added it to the prefix, right? So more or less we'll modify into this actually. To search for it, we'll go as with prefix to search for this word. Okay, and then now like traverse the tree from the current pointer, like till the current pointer, till in a pre-order fashion, and record whether we encounter a complete word or not. Okay, so we'll go ahead with a pre-order fashion. Unless we will find, if we encounter how many words we find based on that, and we'll limit the result to three. Thus we can have like the three only, like the one we did over here, we limited the result to three, like the priority queue. So in try also, like we'll limit the results to three and return the DFS once the limit is reached. Okay, and then we'll add those words into our the final array, the final answer array. The final answer array being this one we had here. Okay, so we'll more or less modify this and we'll try to improve the speed of this particular code. All right, so obviously as you can understand that here in this case we should create a different try class for us, and within the try class there should be something that will help us with the insertion, like insertion in a words in this fashion, like each of the words of this product in this fashion. And then we should go ahead with searching the words, right? Like we should search with like starting with what is there, and then we should also have something like a DFS traversal, like this for the search. We should have a DFS traversal as well, right? So that's more or less we should have. That's within our try class will be there. Now we'll go ahead and modify this particular code we have here. Okay, this particular code we have here, we'll modify this and add our try class to here. All right. As said, we first have an final answer array list, and thus we just return our answer array list. I didn't do anything, just commented out all the codes we had in our previous case. Okay. Now, as said, like we need to have a try class. Okay. Okay, so as you can see, what it did exactly here, I just reused the code we had previously in our previous attempt. So there we had a particular array list, return type array list, that stuff we need to return, and we had this return as well. So I reused most of the code, just implemented it with the try function, like an object of try. And there are two functions that we need to create: the try.insert and try.get word starting. So these are the two that I implemented. So one will be helpful for us to insert the try. Okay, so that's how we just implemented this. This is try, and we are gonna insert in it. So now it's time to work on this try and implement a try. So within this try, we will have a definition for each of the nodes. Like each of the nodes in the try, I mean, like while we are drawing some nodes, right? So this is each of the nodes we had, right? These are the nodes, and there were like joining lines to it, like a pointer, and these are the nodes. So this nodes will needs a definition for us in a try, right? So for this nodes definition, we'll go ahead and describe a node to this try, and then we will go ahead with the defining of functions that we defined before. So let's write the whole thing. This is the solution using the try. I will explain this what I did exactly over here. So as previously I explained what this part is doing. This part is exactly what we were trying to do. Like we are taking each of the words of our products array and then inserting into a try. So let's first see our insert function. So before the insert function, see, we just created a node for our try, that node being each of the nodes with us. Like the node contains an boolean that whether this is a word or not, that like this is the end of a word or not. And along it, it has a list of children. Like list of children has 26 in length, like an array, like a list, array list has 26 elements. All right. So moving ahead, we just had two objects of node. This node object, that the root object and the current object. Current being pointing to while traversing through it. That will be helpful for us. Also, we had a three result list. So this list is useful for us in the way that this list will be storing only three results for us, and that three results will be helpful for us, that we don't need to traverse through whole product list to find three results. Like once we got initial three, we'll not go through the other items in the products, like in the products array. Okay, so that's the three results purposes. Okay, moving ahead, let's see what we have over here. We just have a constructor, and let's look into the insert function. So insert function, we just used our current object we created as a node type object. So what we did, we just initialized it with the root one. So root being a pointer pointing at the first root, and the others will be used for traversing. Okay, so this current is pointed to root, and then for each of the items in our string, like the word, like the products array had a word, and this word needs to be inserted. So we are traversing through the character array of this word. Okay, so we are traversing, and if we find that this children being, this is the list of arrays we had here. So if this children is null, that means previously that node is not found, then we mark it as a new node, and then if it's previously found, then we simply move to its children one, and just finding like the forming the tree for us. Okay, So there's a find, and at last we just mark, like whenever we just reach the end of our particular word, we just mark that yes, that's the end of a word, and that's true. That is true for that particular end. Moving ahead, what we did further, we in the main function we just traverse through each of the elements in our search word and increase the prefix, and within that we simply called our try get starting, like like what starting is being searched over here. Okay, like this function is being called. I'll explain this now. And this function actually returns as a list of string, and list of string is what we need to add to our final answer. Okay, now here gets what starting is like again getting initialized to the root one, like the current getting initialized, and then we are initializing the three results. We are initializing this mainly because we want new elements, like the new set of list every time. If you remember exactly, previously when we used an priority queue in our last video, there we also did something similar to that, so that our priority queue value changes again and again. Like if I show here again, so after this is being done, when you press MOU, U is being pressed. This is a new list should be there. So that's why we implement as like new type element over here. Okay, moving ahead, we initialize that, and then we traverse to each of the characters of this prefix, like the prefix being created and being sent to the starting over here. Okay, we traverse through this, and the thing is, in case we find that the particular children is null, that means a prefix is being typed but the children is null, that means there isn't any word uh, inserted in our try with a particular children. That means we don't have any further, like whatever the result being with us, if it's null, if it's a one element, if it's a two element, we have to return with that. Okay, so we don't need to find any further. Else on the else case, we need to do something like we need to just move into its child, like till we don't get the whole prefix, we'll keep moving to its child. In case before reaching the whole prefix, we find that the particular uh, like the particular prefix element is not there within our try, that means is not there within our products list, then we are actually returning a blank one. So that's the stuff. And after we just got our whole prefix array, like we traverse to the whole thing, now we do a DFS on our prefix and just try to find out the all the elements we have. Okay, like all the elements we have with that prefix, like on that particular node. It's more like, I'll just draw this for you. It's more like, say you had an root node over here, and over there you found your first element, like first character, you found your second character, you found your, say, third character. So this was maybe the prefix you had. Okay, so this was the prefix you had, and after this prefix, say out of this third character, there are multiple nodes going out. Okay, like there are like say 5 or 6 nodes being going out of here, like there are multiple words with that. Okay, so we do a DFS of from this node, we do a DFS of all these nodes. Okay, what does that mean? We do a DFS and just add the first three one over here. Okay, just all the words we need to traverse, and we need to add that. So the first three need to be added. So that's the idea behind doing this DFS one. Okay, uh, then let's move back to our DFS one, DFS function. In the DFS function, see, we just got our current node and the whole word, like a word. I wrote like took a variable name as word, but remember this is actually the prefix where we have. So after that word, we are adding words to it, like characters to it. Okay. The first thing we check is if the result size is 3, that means we got 3 results, we return. So that's a kind of a base case for us. And then if a current is word, like we found a word that is a current is word is there, then we add it to our result. And then the main DFS one is like we get each of the characters from A to Z in our like the children one we have, the children node list we have, and we just traverse to each of the nodes, and then we just find if the current dot children dot get this is null. If this is not null, then we will move into the DFS. Okay, so we move in the DFS with like that particular character, and then word plus c, that character being added to the one, like prefix being incremented to find the whole word, like till we get the whole word with us. Okay, so that's the idea behind this. Okay, now uh, that's the idea behind this, and as you can see, I already ran this once, so you can see that it actually works with us, with our case, and it should work, that we are following the basic ideas over here. So if I just try out with the example cases, then see the example cases is also something that's getting accepted, so we are good to go with submitting our solution. So I just need to pull this back. So this was the one with the first, with the priority queue solution we had, and this one is the one we got with our this node try solution we have over here. Okay, so that's all for this video, guys. I hope you understood how you can implement a try based solution over here, and that's the basic idea behind this. Also, if you haven't watched the initial explanation video of this particular question, then make sure you just go through that. It will be there in your I button, and as well as in your description down below. Okay, all right, guys, thank you for watching the video, and hope to see you soon in my next video as well. Thank you.